Hello, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hafizuddin Rahimi bin Hidib. Today, I would like to present you about a satellite communication system. So, for the introduction to satellite communication system, a satellite system consists of a transponder, which is a radio repeater in the sky, a ground-based station to control its operation, a user network of stations that provide the facilities for transmission and reception of communication traffic through the satellite system. So the satellite transponder is like it acts like a repeater, consists of a receiver and a transmitter. The main function of a satellite transponder, first, is to pick up the transmitted signal from the transmitter on Earth. It's also to amplify the signal, is to translate the carrier frequency to another frequency. It's also retransmit the amplified signal to the receiver on the Earth. Okay, this is the diagram of a satellite transponder. Okay. The signal from the Earth station will go through the band pass filter, which is band pass filter limits the total of noise. Then it will go to the low noise amplifier LNA. It will amplify the received signal and fed it to the frequency converter. Okay. In the frequency converter, it has a mixer, local oscillator, and DPF. So, uh, the frequency converter, it will convert the high band uplink frequency to the low band downlink frequency. Okay. After that, the signals go to the low power amplifier, and then it will go to the earth station. It called as a RF to RF repeater, which is a radio frequency repeater. Okay, so that's my point. I will give to the next partner.
My name is Muhammad Taufik bin Zakaria. My student ID is 2019228674. Okay. For my part is the types of the off-satellite system link. Okay, system link, not the type of the satellite. Okay. Here we got just two types that we must know that was the uplink and the downlink. Okay, for the uplink, it is the path of the satellite signal from the Earth transmitted to the receiver of the satellite. The frequency signal being transmitted from the Earth to station to the satellite is called the uplink frequency up, because it went going up from the Earth to the space. Okay, it's called the uplink frequency. Okay, for an example, the uplink frequency for a C-band is 6 gigahertz. Okay, 6 gigahertz. Okay, for the downlink, it is the path of the satellite signal from the satellite transmitter to the receiver on the Earth. Okay, the retransmitted signal from the satellite to the receiving stations is called downlink, because from the space to the Earth, obviously it's going down, right? So it's the downlink. Okay, for the example, the downlink frequency for a C-band is 4 gigahertz. Okay, notes here that you can see it very obvious that, okay, you can see the different gigahertz, different frequency that from the uplink and the downlink. Okay, not here. The uplink and downlink use different carrier frequencies to avoid the interference. Okay, and the frequency conversion is done in the transponder. Okay, as you can see that what we wrote, the uplink was always must be bigger than the downlink, because the interference that we can see here when we upload, the uplink, we need the bigger frequency, because maybe it's blocked by the cloud or by the rain. It may be interference. That's why it must be higher frequencies than the downlink. Okay, as we can see from the photo there, station one is the on the earth, and the satellite is the satellite at the, oh my god, I'm sorry, the satellite is at the at the space, and we call it uplink. And crosslink is between satellite to the satellite, obvious. Okay, from the satellite 2, go down back to the station 2, and it will be rotated. It will be rotated. It will be a station 1 will be uplink and downlink, and station 2 will upload back. Before giving back the information, it must be the uplink and downlink. So that's how the the system satellite is function. Okay, that's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. Now let's go. My name is Muhammad Afiq bin Muhammad Sabri. My matrix number 2019247408. Now we go to the station, transmitter and receiver. The segment of satellite communication system mainly consists of two stations. Those are transmitting a station and receiving a station. The transmitting station transmits the information signals to satellite, where the receiving station receives the information signals from satellite. Sometimes the same station can be used for both transmitting and receiving purposes. Okay, now we go to the block diagram of a station. Designing of a station depends not only on the location of a station, but also on some other factors. The location of a station could be on land, on ships, in sea, and on aircraft. The depending factors are type of service providing, frequency bands, utilization, transmitter, receiver, and antenna characteristic. The block diagram of digital station is shown in below figure. Figure 5.110 shows an station transmitter. The modulator converts the input baseband signal to an FM, a PSK, or a QAM modulated intermediate frequency. The up converter consists of mixer and bandpass filter, converts the intermediate frequency IF to an appropriate RF carrier frequency. The high power amplifier HPA provides adequate input sensitivity and output power to propagate the signal to satellite transponder. This is figure 5.110. Okay, now figure 5.11 shows an station receiver. LNA, low noise amplifier, which is a highly sensitive and low noise device, amplifies the received signal. The down converter is a mixer and bandpass filter combination which converts the received RF signal to an intermediate frequency IF. The demodulator detects the information signals and feeds to appropriate baseband output. This is figure 5.11 block diagram of an station receiver. Okay, that's all from us.